Hi, my name is Siti Sabrina binti Muhammad Karim.
My name is Nur Syahidatul Alia binti Muhammad Yusof.
Hi, my name is Siti Zulaika binti Zulkifli.
Hi, my name is Anisha binti Ismail.
Hi, my name is Nurin Ajira Yasmin binti Mazlan.
Introduction. Tourists and travelers tend to explore new location and rarely travel to similar location. Due to this, traveler must decide which destination to visit and how to prepare for their stay without sufficient prior knowledge. However, it takes too much time to extract relevant information from social media and the internet. The best solution here would be tourism recommender. By using recommender system, we can automate the process of filtering, processing, personalizing, and contextualizing the massive amount of data available on the internet and social media every day.
Problem statement. Travel and tourism from the perspective of the end users are largely exploratory in character, with few repeat visits to the same destination. As a result, passengers must make selection about their destination and related services with the appropriate prior or personal information. The best choice is to use social media and the internet, but the amount of time necessary to extract essential information is too long. In this case, tourism recommenders are the ideal answer. Therefore, there is a need of recommender system to aid in the automated filtering, processing, customization, and contextualization of the massive volume of the data available and rising on the internet and social media on a regular basis.
Objective. It focuses on comparing key clustering algorithm in order to find an efficient option that can be used in the tourism domain by using social media datasets from travel and tourism contexts. A1. Data searching. Data understanding. Dataset is download. Dataset are also used in the research paper evaluation of partitioning clustering algorithm for processing social media data in tourism domain that are written by Shini Ranjit, A. Sri Kumar, and M. Jatavedan. The dataset instances is 5,456. The attributes is 26. No missing value. Type, nominal, numeric, and string. Numeric attribute is 24. Nominal attribute is 1. And string attribute is 1. List of attribute. We have user in nominal, average rating on church in numeric, average rating on resort in numeric, average rating on beaches in numeric, average rating on parks in numeric, average rating on theaters in numeric, average rating on museum in numeric, average rating on malls in numeric, average rating on zoo in numeric, average rating on restaurant in numeric, average rating on pub or bars in numeric, average rating on local services in string, average rating on burger or pizza shop in numeric, average rating on hotel or other lodgings in numeric, average rating on juice bar in numeric, average rating on arts galleries in numeric, average rating on dance club in numeric, average rating on swimming pools in numeric, average rating on gym in numeric, average rating on bakeries in numeric, average rating on beauty and spa in numeric, average rating on cafes in numeric, average rating on viewpoint in numeric, average rating on monuments in numeric, average rating on garden in numeric, and lastly, class in numeric. Article description. The article that we use explains that the travel and tourism segment is no exception to the growing importance of recommender system in every industry. The enormous volume of data generated through social media and the exponential growth of its usage make this channel a vital source of information for modern recommender system. Due to this, efficient and effective mechanism for retrieving contextualized information become necessary. To handle social context, traditional recommender system use collaborative filtering technique. However, internet and social media as input channel make them less scalable due to their computational demand. Using clustering technique may limit the amount of data considered for recommendation. The social media interaction between travelers, such as review, forum, blog, feedback, and others, can be used to group them into different interest groups in tourism.
So we'll move on to part A2, data understanding and preparation, which is data cleaning in Weka. Data cleaning can be accomplished by applying filters to the data in the pre-process step. In this part, we have the numeric attribute and also nominal attributes. For numeric attribute, there are 24 numeric in this data, which is average rating on church, resorts, beach, parks, theaters, museums, malls, zoo, restaurants, pubs or bars, local services, burger or pizza shop, hotels or other lodging, juice bars, art galleries, dance clubs, swimming pools, gyms, bakeries, beauties and spas, cafes, viewpoint, monument, and gardens. The values of each numeric attribute were shown in the table. Next is regarding to the nominal attribute in this data. There is only one nominal attribute, which is user, where the values from data 1 to 5,456 were 1. Next is missing values from this dataset. There are 3 attributes with missing value. For example, average rating on local services, on burger or pizza shop, and average rating on garden. So for the first step, to replace the missing values, firstly, we need to click the open dataset. Next, choose filter. Next, click unsupervised and then click attribute. After that, we click the replace missing value, and lastly, click apply on the right hand side. The missing value will be automatically replaced with another value. The all missing value are replaced by modes and means from the training data. The reason to remove missing values is to obtain accurate results of the data and reduce bias. Next, we'll proceed with noisy data. Noisy data is the random error of variance in a measured variable, or also known as meaningless data, it is important to remove the noisy data because the results will smooth and have higher accuracy. There are several methods to handle the noisy data, such as mining, regression, and clustering. In order to detect whether there is noisy data or not in our dataset, we will need to detect the outliers first. So the Weka unsupervised filter in the quieter range for numeric attributes were used to detect the outliers. The outliers that appeared as yes, the instances will be removed in the Excel. Next, for this slide, this is the result that shows the first 20 rows of the clean dataset with all the columns.
The next task is data preparation transformation. Raw data is difficult to trace or understand. That's why it needs to be pre-processed before retrieving any information from it. Data transformation is a technique used to convert the raw data into a suitable format that efficiently is data mining and retrieves strategic information. Data transformation includes data cleaning techniques and a data reduction technique to convert the data into the appropriate form. Normalizing the data refers to scaling the data values to a much smaller range, such as from -1 to 1 or from 0 to 1. When multiple attributes are there, as in our dataset, attributes have values on different scales. This may lead to poor data models while performing data mining operations. So, we need to normalize the data to bring all the attributes on the same scale. There are different methods to normalize the data. The first method is decimal scaling. It normalizes by moving the decimal points of values of the data. Next, the z-scores normalization. In these techniques, values are normalized based on mean and standard deviation of the data A. And lastly is min and max normalization. In this technique, linear transformation is performed on the original data. Minimum and maximum value from data is fetched and each value is replaced according to the following formula. In our cases, we use min-max normalization to normalize data. This is because for every feature, we want the minimum value of that feature get transformed into a 0. The maximum value will get transformed into a 1 and every other value will transform into a decimal between 0 and 1. To perform normalization, firstly, we will open our file that has been cleaned before. As the attribute user is not presenting anything, thus we will remove the attribute. Then, click the Choose button, Filters, Unsupervised, Attribute, and Normalize. Here, we need to adjust some properties. So, click on the white space and the properties will pop out. As in our case, we would like to normalize the data into the range 0 to 1. Hence, we set the scale, which is our preferred maximum value, to 1 and the translation is the minimum value, which is 0. Then, click OK and click Apply. As you can see, before normalization, the attributes have values on different scales and it has a maximum value of 5. After normalization, the data has ranged from 0 to 1 only. Some columns may contain so many values that the algorithm cannot easily identify interesting patterns in the data from which to create a model. In these cases, you can discretize the data in the columns to enable the use of the algorithms to produce a mining model. To discretize the data, click Choose, Filters, Unsupervised, Attributes, Discretize. Then, we need to click on the white space to change some properties. In our case, we want to discretize the first to 24th attribute only, as the outlier and extreme values attributes are not suitable to be discretized. Next, we change the bins into 3 because we want to discretize the data into 3 categories, which are low, medium, and high. And here is our data after it has been discretized. The data is discretized into 3 categories and we have to edit the data in Excel to rename the data. Hence, we need to save the data in the CSV format and then open it in Excel. To edit the data, click Find and Replace. Then, in the Find White space, copy the existing data, which is in this case is -infinity to 0.333 for the first categories. After that, in the Replace with space, type the data you would like to replace with the existing. In our case, we would like to replace the data with low. Then click Replace All. Repeat this step with the other 2 categories, which is medium and high. Then, save this file in the CSV format and open it again in the Weka. In the attribute construction method, the new attribute constructs the existing attributes to construct a new dataset that is data mining. New attributes are created and applied to assist the data mining process from the given attributes. This simplifies the original data and makes the mining more efficient. For our dataset, attribute construction is not necessary. This is the data after it has been normalized and discretized. It became more discretized and ordered.
Now let's move on to part B, which is model development and evaluation. Firstly, we open file process from A3 in Weka, then click Classify tab to choose J48. We set cross validation with fault get 10, run the test by clicking Start button, and the result is shown as in the slide. The accuracy is 92.7346%. Next, change the number of fault of cross validation to 20. Accuracy shown is 92.8282%. For percentage split with ratio 70 to 30, we set the percentage split as 70% because 70 is the percentage of training dataset. After clicking Start button, the result shows accuracy of 92.4116%. For percentage split with ratio 80 to 20, we set the percentage split as 80% because 80 is the percentage of training dataset. Click Start and we get the accuracy of 91.7317%. After that, we visualize the tree by right-click on the result list panel. The tree is shown in slide with the tree size is 88 and the number of leaves is 59.
Now move on to the next step, data reduction. This process is to achieve the minimum set of attribute, that's the distribution of the data classes, is as close as possible to the original distribution obtained using all the attributes. Prior to the data reduction, attribute selection should be carried out to choose which attribute should be removed. Now you see the list of the attributes that have been ranked. Now it's shown the normal attribute of the data, which has a total of 24 attributes. Now select the attribute that should be removed. There are 16 attributes chosen, then click the remove button. Here is the result after removing the selective attribute. So once the reduce process is completed, there are only 8 attributes left for this dataset. Here is the comparison between reduced data and normal data. These two types of data is compared in terms of the number of features, which are number of attribute and number of instance. For the number of attribute of normal data is 24, while for the reduced data is 8. For the number of instance, normal data contain 3207 and it's remained the same for the reduced data.
Now we continue to model development and evaluation for reduced data. After reduction step has been applied, we load reduced data in Weka. After that, we click on Classify tab to choose Weka Classifier trees and J48 tree. Set the cross validation to 10 folds and click Start button. The result shown as in the slide. The accuracy is 85.3757%. Next, change the number of folds in cross validation to 20. Run the test again by clicking Start button. The accuracy shown is 85.594%. For percentage split with ratio 70 to 30, we set the percentage split as 70% because 70 is the percentage of training data set. After clicking Start button, the result shows accuracy of 84.1996%. For percentage split with ratio 80 to 20, we set the percentage split as 80% because 80 is the percentage of training data set. Click Start button and the result we get is 86.2715%. After that, we visualize the tree. Right-click on the result list panel, then choose Visualize Tree. The tree is shown in slide if the tree size is 82 and the number of leaves is 55.
From the graph, it shows that there is difference between the accuracy percentage of full dataset and reduced dataset. For cross-validation with 10 folds, the accuracy is 92.7346, but it's reduced to 85.3757 in reduced dataset. Next, the accuracy for cross-validation with 20 folds in full dataset is higher than reduced dataset, which 92.8282 compared to 85.594. For the percentage split, 70% of the full dataset is 92.4116, while the reduced dataset is 84.1996. Meanwhile, the percentage split 80% of full dataset is 91.7317 and the reduced dataset is 86.2715. Hence, as we can observe, the graph of full dataset is higher than the reduced dataset.